So, good morning. So, our topic is about transaction log backup and point-in-time recovery. So, first is what is backup or recovery strategy? The backup and recovery strategy is involving transaction log backups and point-in-time recovery is crucial for minimizing data and ensuring data integrity in a database system, especially in systems like SQL Server, MySQL with binary loss, or Oracle. So the first that we tackle is transaction log backup strategy. So transaction log backups is capture all the change moved to the database since the last log backups. They allow you to restore your database to a specific point in time and recover without losing committed transaction, and then minimize downtime and data loss. So there are three key components of the strategy. So the first is full backup, taken periodically. So this is the baseline for all subsequent logs backup. Second is transaction log backups, taken frequently, like every 5 to 15 minutes. This contains all transactions since the last log backups. Third is optional differential backup, taken between full backup to are reduced every time.
So, point-in-time recovery or PITR. So, point-in-time recovery is mean restore a database into a specific moment before a failure occurred, like just before accidental data deletions or corruptions.
So, how transaction log backup and point-in-time recovery work? So, first is the transaction log backup strategy. The transaction log records all changes to the database, so it records all the changes of the database. Now, in letter B, transaction log backup copies these changes since the last log backup. And third, it allows recovery of all committed transactions even after a crash. So it allows recovery to all the transactions after a crash.
This is the 5-step of perform PITR. So first, restore the last full backup to use the no recovery mode in SQL Server. So second, apply differential backup if they use also using no recovery. Third, it's apply transactions log backup up to the point just before to exit incident. The fourth is solved in the SQL service or equivalent command used to specify the exact time for recovery. Then 5. Recover the database, bring it online using recovery mode.
Next is when is transaction log backup and point-in-time recovery most useful? First is an accidental data loss. If someone deletes or updates important records by mistakes, then this transaction log backup and point-in-time recovery is useful. Next is database corruption. Allows rollback to a safe state before corruption. Third is an application bugs. So usually it undo unwanted changes caused by a faulty code. Next is ransomware or malicious attacks. Recover data to just before the attack. Usually it is attack from the links that you have clicked. And next is system failure. It restores data with minimal loss by applying log backups since the last full backup. What types of database or organization benefit most from using log backup and point-in-time recovery? First is the financial institutions. Banks, stock changes, and payment processors need to track every transaction precisely and recover quickly from failures. Number 2, healthcare systems. Hospitals, clinics, and labs must protect sensitive patient data and ensure uninterrupted access. And third, e-commerce platforms. Online stores and marketplaces handle thousands of real-time transactions requiring quick rollback if issues occurs. Fourth, government and legal systems require full data traceability and must be able to audit or recover any record. Fifth is large enterprises. CRM, ERF, and HR systems used by businesses need to protect operational data and avoid disruptions. Lastly is the educational institutions for managing student records, grades, and learning systems where errors must be.
The advantages. First, minimal data loss. Allow recovery to any exact point before failure. So this minimizes data loss by enabling precise restoration, unlike full backup which may only restore data up to last backup point. Next is granular recovery. You can recover specific change or reverse specific mistake without losing everything. So this is useful for ongoing specific transaction or updates without interrupting the whole database. Next is efficient backups. Log backups are smaller and faster than full backup, reducing storage space and time requirements. This is especially beneficial for a large database with frequent change. 4. Reduce downtime. Enable faster recovery compared to restoring only full backups. So, minimizing system downtime and maintaining operational continuity. 5. Support high availability.
These are the disadvantages.
Critical for system
Number 1.
requiring
Complex recovery
continuous
process.
data.
It requires careful management, backup, sequences, and timing. Restoring a system from backups, especially at a specific point in time, isn't straightforward. You need to apply backups in the right order: full backup, then differential, if any, then all transaction log backups. Why it's a problem? If you missed a step or apply them incorrectly, the recovery may not work. Number 2. Storage overhead. Frequent log backups require significant storage space if not managed properly. Transaction log backups are created frequently to minimize data loss. Why it's a problem? These logs pile up quickly, consuming a lot of storage space unless you have a system to clean up or archive old backups. Number 3. Rest of data lost. If even one log backup is missing or corrupt, full recovery to the point in time may fail. The system needs all the log backups since the last full backup to restore completely. Why it's a problem? If even one log file is missing or corrupted, you might not be able to recover to your desired point in time. Number 4. Administrative overhead. Needs automated scheduling, monitoring, and regular testing to ensure reliability. You need to set up and maintain automated backups, monitor their success, and regularly test your ability to restore from them. Why it's a problem? This takes time and technical effort, especially in larger or more critical systems. Number 5. Performance impact. Frequent log backups can slightly impact system performance if not optimized. Taking backups, especially frequent log backups, uses system resources like CPU, memory, and disk. Why it's a problem? If not optimized, it can slow down the main operations of your system, especially during high activity period.
A bank recovers from accidental data deletion or organization. This is the title of our case study. A mid-sized commercial bank using Microsoft SQL Server for its core banking system. The incident: an employee accidentally executed a delayed statement without a where clause on the transactions table at 10:32 a.m., wiping out all the transactions. The backup setup is full backups taken daily at 12 a.m., transaction log backups taken every 15 minutes. And the recovery process: the full backup from 12 a.m. was restored using no recovery. All transactions log backups from 12 a.m. to 10:30 a.m. were restored in sequence using no recovery. Now in the 10:30 a.m. log backup was restored using stop at equals 2025 to 0507, 10:31 and 59 seconds to recover just before the accidental delete. Finally, the database was recovered using recovery. Now the outcome is all data up to 10:31:59 a.m. was fully restored and no transaction data was lost. The downtime was limited to less than 30 minutes and the bank avoided a major incident and potential regulatory fines.